And hello, everyone. Hello again for those who stayed with us from the very beginning, and to those who have just joined. My name is Yegor Naumov, and I'm the product marketing manager here at JetBrains. And yeah, so in this talk, I'm going to be talking about how we use TeamCity inside JetBrains to build TeamCity. So as you all know, most of you, I guess, use TeamCity on a daily basis. TeamCity is the CI and CDE server for customers like yourselves. But inside JetBrains, for building TeamCity itself as a product, we also need a CI solution. So naturally, we look to TeamCity as a user for our CI and CD pipelines. And we mentioned earlier today that TeamCity is released twice a year. We release major releases twice a year and minor releases up to 5 times between those. But internally at JetBrains, we release TeamCity daily. So each day, there is a new build of TeamCity that we release to the internal users, and that we then, after a number of such releases, publicly announce as a new release of TeamCity. So this is called Dogfooding. So Dogfooding is an essential part of how JetBrains builds products, not just TeamCity, but all our products: IntelliJ IDEA, ReSharper, Rider, PHP Storm, you name it. Everything inside of JetBrains is being dogfooded. That means that our employees use our own tools, and the same is true with TeamCity. So we have an internal server that is called a BuildServer, which we use to provide CI for all our products internally. And this same BuildServer also uses we use it as a CI and CD for TeamCity itself. And the BuildServer deploys a new version of itself every night. And then the cycle continues. We again start using the server. So this all kind of reminds me of the Inception movie and how we need to go deeper to understand what's happening on the next level. So a couple of words about a couple of stats about the BuildServer itself. It's a single installation. We have, by saying single installation, I mean, we don't have multiple TeamCity servers here and there with the project split up between them. No, it's just a single installation, but we have several secondary nodes. And on this installation, there's 1,500 build agents. Of course, this number differs throughout the day. We might have a lower number in the night and then a higher number in some of the peak hours, but we're hitting over the 1,500 mark like every day now. There's 6,000 projects, 40,000 build configurations, 300,000 builds per day, and there's more than 1,000 users on this internal build server. And if talking about our setup, there are basically three pieces of TeamCity. So first is the TeamCity Core. It's the backend part of TeamCity where all the main functionality lives, kind of. And for that, we use a single Git repository. It's mostly built on Java, with Java and Spring, some Kotlin in there. And for Git hosting, we use our internal JetBrains Space Git hosting. For our TeamCity front end, so all that awesome React stuff that Dennis was just talking about, it's also a single Git repository. More, it's the same Git repository as we use for the TeamCity Core. As far as the technology stack goes, it's React plus Redux, Flow, and Ring UI, which is our internally built UI. But in addition to those two components, there's also a bunch of bundled plugins. It's more than 50 last time I counted. And for that, there's a bunch of different version control systems. We have, of course, we have Git for many of them, but there's also Perforce, Subversion, Mercurial, TFS, and a number of broader set of technology stacks, starting from Kotlin, Java, Spring to Microsoft.NET. So this is kind of the diversity that we have to deal with, and we deal with it on a daily basis. And so here's our workflow for the TeamCity Core part. I'll talk about the TeamCity frontend part a bit later, as they have a bit of a different workflow. But for TeamCity Core, it's a trunk-based development. So during the day, all the commits go directly to the trunk. So like random commits. We have from 20 to 40 commits per day on average, depending on the day, depending on how close we are to the release, how many people are on vacation, etc. But generally, that's the number. So we make those commits in the trunk during the day, and then during the night, a review build is triggered on the build server. Now, I have to make a note here that most of our development team is kind of within the same time zones. I think we're generally split up 4 hours between the earliest and the later time zones. So for us, the day and the night is more or less the uniform timings in the day. So the day is where we do the work, and the night is where there's fewer commits, fewer people active, and there's fewer things happening on the build server. So during the night, we trigger the build server review build that takes all these commits and runs them through a bunch of tests. And by the next morning, we have a build ready to be reviewed by the team. So what does it do during the night? And the nightly build basically builds all the binaries of TeamCity, packages them as an archive. And this is basically the same thing that we publish on our website when we release TeamCity. It's just a different version because it's a different build number. But generally it's the same. To get to that, all the commits run through a bunch of tests. So there's one big set of tests for our integration and unit tests. It's more than 20,000 tests that take more than 1 hour, and we run them in parallel on multiple agents, but they still take quite a long time. And there's a couple of dozen of system tests, which actually make sure that TeamCity can be stood up, that you can install and connect an agent to TeamCity, that the protocol works, so like key system functionality works. And then there is a kind of aggregating composite build here. So this build server review build is a composite build. As you can see, it lets you see like all the commits in one place. It lets you see the results of all the tests in one place. It sums up the tests from the integration and unit tests and from the build server system tests, and everything is shown in this build server review build. And I have to also make a short note that this view of the build chain that I'm showing to you, it's a condensed view. And on this slide, I just took a quick screencast of what the actual pipeline looks like. It's a bit more builds than you saw on the previous slide, but just to give you a scale of what it looks like. All right, so that was the backend part. That was the TeamCity Core part, and actually the bundle plugins, they basically go through the same process that I showed you for the TeamCity Core. The front-end process is a bit different. So for the front-end, they don't commit directly into trunk, but they use feature branches for that. And basically, developers, if they want their feature to be, their commit to be merged, they need to name the branch starting with the auto merge prefix, so that the merge robot then picks it up, and based on that, on the prefix in the branch name, it will start a build. And this is possible thanks to the branch build trigger in TeamCity. And you can just edit the branch filter to be only listening to this auto merge prefix and only start builds when a commit to a branch with auto merge happens. And for those commits that developers don't want to get built right away, they just use some other differently named branch names. Further on, their commits go through, so TeamCity prefers a rebase, and it runs their commits through several groups of tests. So there are linter, structural tests, why did you render, special, specific React UI tests, and a number of accessibility tests. And only after all those checks are passed, it merges all the commits into trunk. And I just wanted to give you an example of what it looks like inside TeamCity and what they actually work with inside TeamCity. So when TeamCity reports test results, it can do multiple things. It doesn't just show failed or successful build. It can also show build history. And for example, for our front-end builds, you can actually attach different metadata. For example, like in this case, their tests contain a number of screenshots where the tool takes a screenshot of the changes in the UI and then shows you a difference between an older successful build screenshot and this new screenshot. And if there is a difference, it will fail the build and notify the developers. It's a pretty cool thing to debug visual changes, I think. All right, so we've gone through those processes. We've merged into trunk. What next? Then after the build server review build passes, TeamCity sends a notification to the special channel in our Slack. And what it does here, it mentions 4 people who are on build server duty. And there are 2 people for front end, 2 people for the backend part. It mentions those people. It sends a link to the latest build. It shows the status of that build and just some basic stats of like how many tests have passed, how many changes have made it into this build, etc. So after that, the people on duty open the link, open the build server, and they basically review the changes. And this is a manual review process. What they do is they open the changes tab and just go through the commits that made it into this build and just make sure that their goal is to make sure that there are no breaking changes. There's no changes that could break the like agent server communication or any cleanup changes that could delete all the build history data from our build server, so that nothing catastrophic can break. And there's also a secondary goal to share knowledge. This is basically a code review. So developers can share knowledge between themselves on how to implement something in a more optimal way, or what's the best way to make a change to a specific subsystem of TeamCity. And if a breaking change is found during this review process, we have to stop the process. We have to stop the chain. And there are basically from here, there are 2 ways to go. Well, one is we don't release a new build of the build server this day. And 2, we implement a hotfix. And I'll talk about that a bit later. But from here, on the other hand, if everything is good, we trigger the merge into the build server branch. So TeamCity will take all those changes from day 0, and it will merge trunk onto the build server branch. And note here that the new commits that came over like during the night or during the day 1 on this scheme, they will not make it into here because they did not go through the build chain before. They didn't go through all the checks. They will make it into the next build on the next night, basically. And one more cool thing about this, remember I mentioned you that we have over 50 different bundled plugins, each of which lives in their own repository. So this merge operation is not a single merge. It's a merge across 50 different repositories. And what TeamCity does here, it basically merges 50 different commits and 50 different repositories all into the same build server branch. And what it does, it takes the snapshot of when those commits happened, and this helps it merge the commits over the same time frame, over the same specific time point when they happened into the same branch. So this is basically only possible with the snapshot dependencies within TeamCity, and this is a pretty cool feature, I think. Okay, so if everything is good from this point, we will again build the binaries of TeamCity, package them in the archive. There's another quick check by the people on duty during the same day, and if everything is good, then they manually apply one of the tags, either a deploy tag or deploy manual tag. And these are the tags within TeamCity, so they just put the tag on the build, on the finished build. And TeamCity monitors for this, and the build server starts another part. So the build server now starts the upgrade of the build server. And yeah, here we have the trigger, the start build trigger that watches for some specific tag. In this case, deploy manual. The difference between deploy and deploy manual is not that big. Basically, the deploy starts like in the middle of the night, and deploy manual starts closer to the morning when there's someone who can kind of watch over that build just in case something goes wrong. Yeah, right. So from day 0, we merge into the build server branch, and on that branch we start the build server upgrade procedure on the night 1. And this is how it works. So our build server lives on a machine which is locally hosted on one of our vSphere window VMs, and there's a dedicated build agent that lives on the same machine, and this build agent is only dedicated to this specific build configuration. So you could see here on the left, there's this. It lives in its own special pool, and there's only 2 build agents are in this pool, server maintenance, and all these agents do, they just run these build server upgrade builds. They don't run any other builds. This is quite important. So this dedicated build agent lives on the same node as the build server. What it does, it downloads all the binaries from the build server. Then it stops this build server. And because the server is stopped, then there is no access to it, neither by the users of TeamCity, of the build server, nor by the agents of the build server. This means all the traffic is rerouted to our secondary server, which, while the main build server is down, is stood up, and it takes on all the load, basically, from the users and from the build agents. And then the agent replaces the files on the server, on the machine, and restarts the server. Another cool thing about this process is that at this time, when this agent is performing all those actions, and while the build server is down, the agent also reports its progress and the build logs and all the results of the build to that secondary TeamCity node. So any user can just open that build and just watch in real time the progress as this agent is updating the build server. So once the build server is restarted, we don't need the secondary node traffic anymore, and the users can go back again to the build server. The agents can also report directly to the build server from this point. And now, after this action, we start the upgrade of our secondary node. This is the VCS node, as we name it. And it's basically the same process. There is also a build agent that lives on the machine where the secondary node lives, and it does exactly the same process as I just showed you. And also, while that is happening, because we've upgraded the build server to a new build of TeamCity, all the agents also need to be upgraded. And so all the agents, including that same agent that was performing this upgrade, they start the upgrade to a new version automatically. So the cool thing here is that, first of all, the agent can continue the build without the main server being up. And second of all, that while with having this secondary node of TeamCity, this same agent can report the progress to that secondary node during its updating the initial main node of the build server. I don't know. To me, it's pretty mind blowing how it works. All right, so I promised to tell you about how the hotfixes work, and this is it. So sometimes it so happens that we need to implement some hotfix after the initial build is built and after we've merged our trunk commits onto the build server branch. And yes, we can do that. We do that after that merge operation. So whenever there's a hotfix, a commit with a hotfix, we can cherry pick it from the trunk branch and merge it onto the build server branch. And again, start the build server upgrade already with that change in the list of changes. So in summary, each commit makes it into the production the day after the next one. So if I make a change to TeamCity today, everyone at JetBrains, all 1,000 users across 40,000 different build configurations receive that change, and they can use it like the day after it was made. And this is our core process here at JetBrains. We love dogfooding. We love using our own tools. And this is how we set up our continuous deployment. But then the next day, everything continues. Everything happens again in the same cycle. And going back to movie references, that reminds me of the Groundhog Day movie, and the process repeats itself. So yeah, that was it. There's a short story how we develop TeamCity internally, how we use TeamCity to do that. Hope you liked it, and I'm open for any questions.
That's great. Thanks, Yegor. This is always a really interesting process. I remember when I first joined JetBrains and learned that this is how we're building and deploying TeamCity with itself. My mind was also blown a little bit. So we don't have any major questions in the chat. One of the things I wanted to ask is, one just came in. From a TeamCity build agent perspective, I know a lot of customers I talk to are trying to figure out, where should we host these build agents? How do we run them? So just out of curiosity, what are we doing internally at JetBrains? Where do we host the bulk of our build agents? And I know it's spread out across a bunch of different development projects, but could you talk to that generally?
Yeah, generally, well, it's hard to tell decisively because they're, as you said, spread out. There is more than 1,500 build agents across different projects. We have a bunch of them in the cloud on AWS. We have a bunch of them on-premise running on some of our like hardware, basically in our offices. We also have the internal vSphere setup with the private cloud. And as I mentioned, this is where our build server runs. So, for example, the agent that upgrades the build server that I mentioned is hosted on that same VM on the vSphere, and it's just a Windows machine basically. So yeah, kind of all over the place, wherever people need them, wherever their projects need to be built. We have, I think, everything here internally.
Great. Yeah, another question that I frequently get is from customers who are trying to figure out where they want to host their TeamCity infrastructure is, what platform are you using? What database are you using? And I usually point them to the documentation. We do support a number of different databases and a number of different operating systems. TeamCity is a Java application, so it can run just about anywhere. But what are we doing internally at JetBrains, if that's information you can share?
Yeah, we're on Windows. We're, in terms of the machine themselves, we run. I think they're run on as I said, vSphere with Intel Xeons. For our main node, it's a pretty bulky machine with 36 CPUs and over 70 gigs of RAM. But also for the secondary node, it's basically the same type of machine, but with a bit of a lighter specs. Like it's a smaller Intel Xeon with 16, I think, CPUs and 50 gigabyte RAM.
Right.
Yeah.
And we were having some good discussions earlier today in the chat. If your TeamCity server is experiencing heavy loads, a lot of times that comes from VCS polling. So we would recommend, maybe setting up a multi-node architecture, or one of the better things you can do in those cases is set up commit hooks, so that your polling intervals, if you're polling, 10,000, 100,000 VCS routes, maybe you're not doing that anymore. That's a good way to reduce the load. A couple other questions from the chat. I don't know if you know the answer to this. How many commits per day on average go through your pipeline before we get into the nightly build, at least on the TeamCity side?
Yeah, so as I checked, it was from 20 to 40 commits, something around those lines. Of course, as I said, depending on the number of developers basically in the office or working from home these days, depending on the day of the week, etc., it can be more or less, but in general, it's tens of commits.
Yeah. Can you talk generally about our process for rollbacks or backups when things go wrong?
Yeah, well, we can do that manually, basically. But I was very interested in that. Like, if something goes wrong, what happens? And generally, the pipeline itself, the way we have it set up, rarely anything goes wrong. It looks like, right? Knock on wood. But historically, we have not had many problems with this pipeline. And when it does, so there are people on duty that I mentioned that overview that deployment process, and they can kind of take over and just manually restore the build server from the backup.
Yeah, I'd say one of the advantages of the process we're running here, especially if you're a customer who has a critical bug fix, oftentimes we can produce emergency releases of TeamCity. If you're encountering a bug fix that is really causing some serious problems in your environment, that's a situation you obviously want to escalate to support, to your account rep, to myself. But if it's something that we've been able to implement a fix, we may be able to get you an early version before the main release. One of the last questions in here sort of relates to our backend processes. And we're obviously building a lot of projects internally at JetBrains, all of our IDEs, our external tools. How do we manage build priorities between different projects? And Justin mentions that some of their projects tend to have a lot of chain build configurations. And it could quickly use up all of the available agents. So what are some of the best practices for making sure projects have agents available? Not buying more licenses. Justin, we would love to have you buy more licenses, but obviously that's not feasible.
That's a universal answer. Just get everyone a build agent. That's it.
Right.
But seriously, so I would say agent pools is something that you need to utilize in that case. Just split your agent in different pools, assign those pools to a limited number of projects, and just have those build agents only run builds from those projects. So the very edge case scenario that I mentioned in our presentation, where there was a one build agent assigned to one specific build configuration, that's a very edge case scenario. You don't probably want to do that just because it will be idle most of the time. But assigning agent pools to a number of projects would definitely make sense.
Yeah, and this is another scenario, we've been talking about it all day, where being able to utilize cloud profiles, whether that's with on-premise VMware vSphere agents or with cloud agents through AWS, can really be beneficial because TeamCity is going to manage pulling available licenses and returning those back to the pool when they're available.
And of course, the move to top functionality to promote your builds to the top of the queue. Yeah, sure. If you have the permissions, you can always use that as well.
Yeah, always helpful to be an administrator, right? Yeah,
exactly.